The last transformation we have to look at for section 1.4 is the absolute value transformation. You know you have an absolute value transformation when you see something like this, a function where it is placed inside of these bars, these absolute value bars. And the way that the absolute value function or transformation works is it takes all of the negative portions of the graph and flips them into the positive quadrants. In other words, it takes the negative portions and reflects them across the x-axis. The positive portions it leaves alone because you know the absolute value of a positive number is still positive. So what I'm going to do on this graph, I have these regions here that I need to reflect across the x-axis. Everything else on the graph is going to stay the same. So, starting with the first one, checking my scale very quickly, it looks like we have the point -7, -1. So I'm going to leave the -7 alone, and the y value is going to flip up here above the x-axis. And just mimicking this function is going to fall down and hit f of x, or hit the x-axis right there. The positive portion of the graph stays the same. You get to this point, and the graph has now gone below the x-axis. So I'm going to take the minimum here. It looks like it's at roughly -1.5 maybe, checking the scale on that x-axis. It looks like that scale is by 2s as it's marked. And then, it looks like that scale is by 1s. But if you check the y-axis, that scale is larger. So I take this portion of it, go to this, it looks like it's at roughly -1.75 on the x-axis, and it's at -1 on the y. And I'm just going to flip it up here, that shape, until I hit the x-axis again. And it flips back up. So this portion was already above the x-axis, it stays the same. I do the same thing with this one. There is the absolute value of whatever that thing was, the absolute value of f of x. On example 4, we're given this function. We can put it in our calculator and see what it looks like. Let's work with it by hand first and then use our calculator to check. So we're doing the absolute value. We need to take a look at this, and everywhere it's below the x-axis, we flip it above the x-axis. Now we have a significant portion here, hitting mins and a local max and another local min, all beneath the x-axis. So what I'm going to have to do is get a few more points up here to connect my graph so that I have that reflection happening. So at this point, let me trace down to here. That is my first local min coming in from the left. It looks like it is at -1.25 perhaps, -2. So I'm going to take this and I'm going to flip that up to 2. I need another point to figure out what's going on. So I'm going to take this local maximum, and that local maximum happens just this side of that grid mark, and it's not too far below the first grid mark on the y-axis. So I'm going to flip it to right here. This minimum is located close to this hash mark. I'm going to take it, I'm going to leave the x alone, I'm just going to flip the y to about right there. Once again, I'm doing a distance measurement. That's one grid mark and a little piece. So I'm doing one grid mark and a little piece. And then we're back down to the x-axis. Now, this is enough to graph it if you have an idea of how this reflection is going to work. If you need a few more points, we can grab them. We can take this point, which is at -1, -1.5 perhaps, and we can flip it up here to that, so we can get the shape of what the graph is going to be doing as it heads towards that red mark. Perhaps maybe this point might be a good one to graph also as we reflect it across the x-axis. It looks like it's at -1/2, on the y. So I'm going to take this guy and I'm going to flip it to right there to a positive 1/2 on the y. Let's see if there are any others that are nice to grab on this. We cross the x-axis right here, so we're going to go across the x-axis the same distance to get that turn in to go towards that red one. So I think we probably have enough here. Let's graph. We have coming down the graph, it's above the x-axis, so it stays there. It hits the x-axis and it sharply turns. It goes through these points we have marked. We hit the x-axis again. Trying to hit my points there. There we go, finally. We hit the x-axis again, and then we trace along the positive portion of the graph. We hit the x-axis, so we sharply turn and head off to that is now the absolute value of f of x. Now let's get this on our calculator and see what it looks like. We are going to do second catalog, grab our absolute value, and I'm going to type in this function. So negative x to the 5th plus 3x cubed minus x minus 1/2. And I'm going to use the fraction button, which is alpha y equals, choose number 1, and put in the 1/2 graph, and there's our function. It's a little strange looking, but it matches what we have on our paper, right down to our minimum becoming a local maximum. This local maximum is flipped to a local minimum. See how everything is flipped around on the negative? And then the positive side stays the same.